Scaling out a PHP application to multiple servers requires work and can cause serious bugs if you don't address each pitfall individually and with care. If you have never run a PHP on multiple servers, this step can feel extremely daunting and scary. But I'm here to say you everything is fine. Once your application is scaled out to more servers, you get a lot of benefits: scalability, fail safety should one server go down, rolling updates and server upgrades without downtime. In this video, I'm going through a checklist of 7 things that you need to address when scaling out your PHP applications to multiple servers. While the advice in this video holds true for PHP applications in general, details may vary a lot between different platforms, hosting providers, and your application architecture, what libraries and code you're using. This video focuses on deployment in a more classical setup with a physical or virtual server infrastructure and not in container-based infrastructure. This I might add in a dedicated video in the future. Hi, I'm Benjamin, and I'm helping PHP developers with performance and scalability for over 10 years. The first topic we'll need to address is deployments. How does the code actually get served to multiple servers? That means your PHP application code. When you update it, how do you get it out to the servers at the same time and make sure that all servers are running the same code? So we have a small example here. Users are accessing your application, PHP, Nginx, Redis, MySQL through a single server. And we want to scale this to multiple servers. So let's sort of set up this deployment scenario. So we have 1 server, 2 servers, and we are conveniently ignoring the case how users are getting there for now. And the question is, what do we do to get the code PHP to the same basis? So the first thing that we can do is we can introduce a new server, which is a network file system. And we could build our deployment in such a way that we have the PHP code on this network file system. That means we only have to connect to 1 server, write all the files and updates there, maybe make our deployment, and then both servers are using the network file system to get the PHP code. Connecting this here and completely failing. Both of them are connecting to the server to get the PHP code, and we don't have PHP code here anymore. So this is one way of sharing the code. Then you could run a deployment tool, composer, everything on this to make it work. The second approach would be to keep the code on. So downside of this is network file systems are a bit slower. I mean, it's a very old standard, so it's very stable, but they are slow because obviously the code is loaded from the network. But with opcache, once the files are in opcache, that isn't a big problem anymore for PHP code execution. So unless you're doing something wrong in your application, this is an approach that is simple and can work if you need to get started fast. Another approach that I often see is that we put the application in maintenance mode. So, and then we deploy the application on all servers, and then when the deployment is done individually on each server, then we remove the maintenance page. So let's say we have Git deployment here on every server, so we pull the code changes, do the necessary updates in place, and as long as this is happening, we have a 3.no.1 maintenance page, which is served from the Nginx servers. The simplest idea here is to configure Nginx to have a specific file they look for to see maintenance mode, and then if they see it, they serve this page notifying users that the application is currently down for maintenance. This obviously has the downside that the site is not available all the time, so it's not a 0 downtime deployment, but it's a very simple deployment to introduce if you want to make sure that you have time to update an application on multiple servers before allowing it to run again. So let's look at the third approach that we are going to look at. Is we are going to have a dedicated machine that is responsible for the deployment. It doesn't have to be its own machine. It can also be one of the two machines, but usually it makes more sense to have a dedicated machine because that provides some additional isolation. In our case at Tideways, this additional machine is also the SSH jump host. So this way we can only connect to our infrastructure through this, we call it admin machine, or it could be the deployment machine. So what does this do? It, for example, Git pulls the code. It could also, let me pick this logos here. So on this machine, we are pulling our changes or pushing our changes to them using different tools, Composer or Deployer. So Deployer is one PHP-based tool that allows to orchestrate this kind of deployment, performing tasks on multiple machines. There's also the possibility to use Ansible for that, which is what we are doing at Tideways. And the way this works is that this machine here prepares the code for a new release, and then we are pushing the code here to these servers once it's done. This could be done using AirSync, for example, or any other means. So you could also have this machine here call git pull on all of the application servers. One thing that I recommend doing in this approach is to have one directory for every release, and then you deploy and prepare the code base. The application is still running on the old folder, and then once the deployment is done, you switch the symlink for the sort of current directory that is active to the new release version. And this way you can achieve sort of a zero downtime deployment. And this way you only have to perform the complicated and failure-prone steps like Composer installation and so on the single machine, and then move the code using AirSync to the application servers. The next step to address in the checklist for scaling out a PHP application is load balancing. So we haven't talked about a user reaching our multi-server setup yet. So for this, we actually need yet another server. And this is depending on your infrastructure, either a server that you set up yourself, or various infrastructure providers also just provide this for you, manage this for you, and you don't have to manage it yourself. So what does managing a load balancer mean? Is this something difficult? No, it's actually just Nginx again. So it's an Nginx server, and I can show you here using Nginx as a load balancer is a very common strategy. The way it works is you define an HTTP or HTTPS server, define multiple upstreams, which are our application servers, and then you sort of declare this as a server and proxy all traffic to those servers here. So the upstream is an application name with all these servers, and this load balancer acts as a proxy to push all the traffic forward. So it's the first time I'm using this whiteboard thing, so you see how terribly newbie I'm about it. So actually the other way around. Let's do it this way. So traffic is coming from the internet, and it's going to be sent to the servers by the load balancer. And then we have a user here. Let's take the user here to make it all shiny and nice. Okay, so user hits our website, example.com. The load balancer accepts this traffic. They can also offload SSL already, so they can handle SSL and then move forward the traffic to the application servers over HTTP if you have a secure network between these servers and you don't need to encrypt the traffic. So one thing that we see in this example here is still Redis and MySQL are on those servers duplicated. So usually either you have Redis and MySQL running just on one of those servers, or if you're starting to fan out with servers, this would be the point where you also introduce sort of one Redis server, one MySQL server, and then you connect the applications with both servers, so they are talking to dedicated database servers. So the benefits here is scalability. If you don't need that for now, then it's okay to keep database and Redis on one server. One problem with this is that they need to be scaled at different sizes, and so it doesn't make them comparable very well. So the server with the database would need more cores, more RAM compared to the other application server, and it would also introduce different latency behaviors, and this could make it more difficult to debug the default behavior of performance. If you have a default network trip to the database from any server, then this is something you can reliably trust to be the same or from every server. Okay, so this is our setup for now. The next thing that we need to talk about is sessions. So with a default PHP application, sessions are usually stored on the disk. And if you're using multiple servers, then sessions cannot be loaded from the disk anymore, because the load balancer is randomly sending the traffic from a user to different application servers. And if these application servers need to log in the user with the session is loaded from disk, then this will introduce very weird behavior on the multi-server setup. So sessions need to be moved to some kind of database. The simplest approach for this historically has been to use, so you can do this by calling session safe handler here, overriding the session safe handler and setting it in code. And historically, the easiest way to do this is with the memcache or memcached extension. They are usually shipped in every distribution. It's just one package. Installing memcache is also very simple, and it's also a very reliable piece of software. It doesn't keep the sessions around after restarting memcache, so that's one downside. But if you put it on a dedicated server, usually it can run almost infinitely, and there's no maintenance needed for that, or not a lot of maintenance needed. And you can just update in any setting for the memcache support and set the session handler to memcached, and then as a safe pass, specify where the servers are, and then you're already using memcache sessions in your application without having to change a single line of code. And this is a very good approach. If you have a legacy application, it would be very difficult to do that. It's also possible to do this with the PHP Redis extension. So if you're using Redis already and want to store the sessions in Redis, then you can do this installing PHP Redis, and it also has session support. Let me look for it, PHP session handler. So again, you can configure the session safe handler to be Redis, and here's an example. Specify the hosts where Redis is, and it will use it to store the sessions in. So let's decide in our graph to put the sessions into Redis. We already split this up. So we have a dedicated Redis server, and we are using the sessions on Redis to make that work. Sometimes your application requires the sessions to be very stable. In this case, I can also recommend using a database as a backend for the sessions. Since we need to access a central database anyways, we already have a single database and we can store sessions there. It's a little bit more difficult because you have to write a custom user session handler accessing the database, but you'll find a ton of examples out there in the internet, or your framework already provides an implementation for it. So now that we have sessions handled, the next question is, what about the file system in general? We moved off the sessions, but what about the file system in general? So we have two servers on there, and depending on your application, users might upload files, and the application might download files from the internet and store them on disk, or you might be using SQLite databases on disk to store information. All these things have to be handled if you now have multiple application servers. So the first thing that we need to talk about is using an abstraction for the file system that allows us to store files remotely. So again, we talked about this in a scenario before. We can use NFS. So what if we had a server that provides an NFS network? This doesn't have to be a dedicated server. It can also be just one of the servers that you have. But it also can be some kind of storage system that exposes NFS. A lot of hosters provide this to you. So what you can do is, if you are using file uploads, then you can configure them to go to the network file system. And you need to rebuild your application to use the network file system path. This is usually simple because you already have some configuration variable for the path for the uploaded files, for example. If the uploaded files are put into the public directory of your web application already, then you need to make this directory a symlink of your network file system. This is the most simple approach. Another approach that you could take is that you are using a remote object storage service such as S3. So S3 from Amazon is becoming sort of a protocol that a lot of vendors are implementing. So a second approach could be that you're using a stream wrapper to write all the files to an S3 compatible device. What is the benefit of a stream wrapper? Let's look at the Amazon SDK stream wrapper code. So we have a client here with the options. We registered the stream wrapper. And then the benefit of this is that you can continue using file get contents, file put contents, fopen. So if you have a lot of file related code in your application, then you can use the stream wrapper to make it quite simple to move everything over to a remote object destination without having to change a lot of code. If you have an application where you have the code under control, then you might be using an abstraction like Filesystems already. It's a file system abstraction layer, and it provides different implementations for file systems. For example, also an S3 adapter, which again, with all the vendors usually providing an S3 compatible API, you can connect it with a lot of different services. And the API for this is you create a client, and then you have an adapter, and then you have the file system here. And you can see here in the documentation the file system API. So you have different ways of writing and reading to the file system in a way that abstracts the underlying vendor that supports this. One thing that you need to account for is performance with this, because file system operations are so ubiquitous in applications usually. If you have written your code to be aware of sort of a local disk, assuming a local disk and not the performance overhead of the network, then it could be that, like using performance monitoring such as Tideways, we see here an application performance split down to the individual layers. We can see here SQL, Redis, and various things are contributing. And we can see, if we look at a trace, that the trace is performing file operations for just 1 millisecond. But say we would have moved this over to F3, we are doing a lot of operations here, and we would see our access to this remote file system go to over at least 100 milliseconds, then this means the performance of the application radically changes. So this is something that you need to be aware of. Coming back to our application diagram, one thing that we now need to address when scaling an application to multiple servers is cronjobs, because we need to find out where to execute cronjobs in a way that they don't interfere with each other. Let's say if we have just naively duplicated server 1 and server 2, and they have the same cronjob configuration running. This means the same cronjobs are executed at exactly the same time twice, and if you have multiple servers, 3, 4, 5 times. This is not the behavior that we want, because cronjobs usually perform operations that should be done only once. So what are the different strategies here? We could, and this is the most simple strategy, designate one of the servers to be the cron master. Cron master. The way it works is that we only configure cron job setups on this one server, and this way we are making sure that they only run once. The problem with this approach is that we don't have a reliable server architecture anymore. One benefit of the approach of having multiple servers is that any of the servers can go down. Just for maintenance, for example, installing new packages, restarting, or replacing the server with a new server with a better operating or more newer operating system. If you're using this approach, then you need to be careful that one server is always the active cron master, and if you're doing this manually, then this means this is some work. And if you have downtimes of this one server because of hardware failure, for example, then even if your application is available through the web interface, cronjobs are not running, and this could have potentially bad consequences. For example, if the cronjob sends emails, like for example password request emails or double opt-in emails. So a better approach would be to allow the cronjobs to run on all servers, but we have sort of a cronjob leader. One server is designated to be the current active leader executing the cronjobs, and all the others are on standby. And the way you can implement this is using multiple approaches. One simple approach could be that you just have a database table where the name of the active server is in. Then every minute when a cronjob is executed, the individual server runs the cronjob, all of them run them. They look, am I the server designated for running cronjobs at the moment? And if not, they stop. If yes, they perform the task. This makes it a little bit more scalable, and either you can manually manage this table by updating the servers if necessary, or you can come up with a mechanism to update this automatically if the server being active goes down for a while. You can make this more complex by introducing dedicated software for doing this kind of leader election. And the usual softwares that are picked for this are Consul and Zookeeper. They both are in the medium and high level of complexity operating. So only introduce them really if you have very specific and advanced needs. Personally, I would recommend against doing that and finding more simple approaches like the one with the database or with sort of server-wide locking. There are many different ways of doing this, spreading the cron jobs without running them in parallel. Once you have cronjobs set up this way and you have a mechanism that runs them on different machines, maybe provides some automatic selection of where they are run, you need to be sure to have some advanced monitoring in place. On one server, usually it's not necessary that much because you can rely on the one server being up. You know it's up, so you know the cronjobs are running. But with a more complex approach, you might be missing cronjobs. One way to do this is with a tideways heartbeat monitoring, where you can specify that individual cronjobs should be running once every day, once every hour, or something like that, and then tideways will notify you if that's not working. Another tool for this is from our dear friends at ODear, who provide cronjob monitoring that allows you to monitor that cronjobs are running by sending HTTP requests about this cronjob run, and they sort of checking that this really happened in the specified interval. Let's continue with the next check item that we need to handle on multiple PHP server architecture, and that's database migrations. Database migrations is sort of a special case of deployment and cronjob execution. But it's also a task that should only be run at a single time. It should not be run multiple times because that could have devastating consequences. And the way to do this is either to use the mechanism for the cronjob leader election, only run it on like one server, or since usually this happens during deployment, if you decided to use an admin machine, then what we are doing at Tideways is we run the database migrations on the admin machine and an early step of deployment. And then the database is already at a new schema. The application is still running at an old version, and then we switch over to the new application at a later point. One thing that this requires, which is not specific to deployments or scalability, is that database migrations need to be written in a way that multiple versions of the applications can run with the different versions. And we achieve this by only adding tables, only adding columns. Never dropping tables, never dropping columns. Only if we are very sure that they are not used across multiple versions, we can start cleaning up old tables, old columns. The last thing I want to address today is logging and errors. So with an application that scales out to multiple servers, you also have log files on multiple servers. And the question is about when debugging and looking at stuff, how to look at all the log files in a way that helps me debug issues, troubleshoot problems, find certain ways, auditing access to the system. And what you can do in the most simple approach is to use a software that allows you to connect to multiple servers at the same time and performing the same operations. So my colleagues are using a software called Tmax Xpanes for this, but there's also different a software called Cluster SSH, which also allows this. The way it works is you specify here a command you want to execute on a set of servers that you have access to. You can use patterns for that, and then it will perform this across a fleet of servers. This way you can tail log files in multiple servers. You see them in panels, and it provides a way of debugging across multiple servers in a simple way without having to run a lot of additional software. For an application that is bigger and has more operational needs, it makes sense to look into a software that centralizes log files. There are a few different ones. The Elasticsearch Grafana stack is there. There's Greylog, and I wanted to show Loki shortly from Grafana, which is also software that we are using at Tideways as a server to aggregate log files. Usually they provide sort of a central interface that you can log in over the web, and then you can search for terms in the log files through the web interface. A second thing that you need to handle in applications that are running on multiple servers is error and exception tracking. It's a special case of logging, but I would even recommend for a single server setup to use an exception tracking tool such as Tideways. I put it here in the server graph. So the way it works is you connect. The way it works is you learn how to use Canva. You connect your PHP to Tideways, and it will collect errors that are happening. It will aggregate them so they only appear once. It will send notifications when they are happen for the first time or repeatedly. And you can see in this example here, we are seeing a list of all the errors. We see here that they happened multiple times. There's a workflow engine on top of it where we can see errors are being acknowledged, have a state open, also closed is available. And we can see and work on those errors from a centralized user interface, only seeing each individual error once and not across multiple servers, multiple lines and log files. I remember working on my first multi-server PHP application many years ago. It was an amazing feeling getting to work and run. And since then, I've benefited greatly from using this architecture and pattern, for example, with Tideways itself. Single servers can go down, so hardware failures do happen. You can do rolling upgrades to new PHP versions, to new versions of the operating system without the application being down. And you can scale the application to tens of thousands of requests per minute easily. I hope this video gave you some helpful pointers and ideas to achieve multi-server setup for your application. If you want to follow my channel on PHP performance topics, please subscribe, and also you could subscribe to our newsletter. Link is in the description. Bye.